want to think through basically how we're doing this, and one of the ways to imagine that is just all the ways that we can get it wrong. Okay? So we're going to build up our chromosomes again, and we're going to have these replicated sister chromatids like this. There's going to be this primary constriction where we're keeping the centromere the cohesin intact. But I'm going to draw a lot of different ways that we could do this. Okay, so we're going to have, let's build 5 of these. Okay, there are some chromosome organization problems. So again, these are replicated sister chromatids. So you can imagine, actually, they're all independent units in the cell. We have all these things here. Primary constriction, centromere kinetochore. We'll come back to the machine in a second. Each one of these needs to attach to the spindle. Okay. What I really want is the thing that I've already drawn. Okay. Here you have microtubules coming in. These face one way. These face another way. And this is like, gold standard. This is what we want to achieve. And we're going to refer to this as bi-oriented. Okay. So it's oriented in both directions, one attached to one side and one attached to another side. Okay. There's a lot of ways to get this wrong. So each of these 4 chromosomes is going to have an issue. So in this case, for example, we could do something really bad and just not make any attachment. So here I'm not going to draw any microtubules. These chromosomes just didn't attach to the spindle. They didn't attach to those microtubules. It's completely unattached. This one here, which needs to be a little bit fixed, has some, again, slight chromosome structural issues that we now have corrected as the cell. I'm going to make an attachment, but I'm only going to make one. Okay? And so this is going to be monopolar. It's going to attach, but only to one pole. So this is problematic, and I think you all can see if we tried to actually distribute them and pull on them, it's sitting in the middle of the cell. There's nothing attached to it at all. It's not going to move anywhere. It's going to sit floating in the center of the cell. This one's also going to be a problem. Even if I manage to separate those sisters and move forward, you're only going to pull one direction. Maybe the other one's going to sit floating in the middle of the cell. Okay? So monopolar attachment is definitely not what we want to achieve. I can still do this bad, though, even if I make attachments to both sides. So for example, in this case, I'm going to make attachments to both chromatids, but they're going to be both coming from the same side. And this is going to be a state that we'll refer to as centelic. And in this case, both chromatids are attached, but basically it's this situation right here where I'm holding on to both of them, but I'm holding on to them both in the same way. And this way they separate. They're still going to both segregate to the same spindle pole. And so that's also a really catastrophic way to do things. And then I'm going to make yet another state. So anything that can go wrong will. I'm going to build in a bi-oriented situation. Oh, I did it right, but oh, accidentally I made another one over here. And so this one here, this one kinetochore, this one chromatid, is actually attached to both spindle poles simultaneously. And this is a state that we're going to refer to as mirror-telic. And again, these names don't matter as much as the concepts that they underlie. And again, here we've got that chromatid. I've attached to it, but from 2 different directions. Just imagine I'm going to rip this chromosome apart. It's going to be a really nasty thing to do. Maybe it's going to hold in the middle of the cell instead of segregating. This is definitely not what we want to achieve. Okay? And so we need to be able to build these connections between the microtubule structures that are here and the key machine by which they're attaching, called the kinetochore, in which we're actually creating attachments, but knowing that we did it right. We've got to be able to recognize and say, oh, this is a problem. This we need to fix. We need to make attachments. It's bad. Still missing attachments. But even once we've made this attachment here, like they're bound. They should be fine. But they do not have the right context to be able to segregate their chromosomes normally. And so we need to think about not only making these connections to distribute them, but how do we know that that's correct?